Okay, good day guys. So, we'll start our online classes this week. So, this is the module for Gen Chem 2 this week. So, on the first day, we're just having the continuation of chapter 15 acids and bases. So, at this video, we'll just have 15.12 the Lewis acids and bases, and then another on another video, I will discuss the 16.3 buffer solutions, so that the videos must will be uploaded faster in YouTube. Okay. So you may read the PowerPoint presentation on Edmodo while we scroll this video, since most of the letters or figures are not very visible in this video. So you may try to have a clear copy of the uploaded presentation so that you can scroll the previous slides. So that's it. Okay, so we'll start with Lewis acids and bases. So far we based our definitions on the Brønsted's definition of acids and bases. So when we say again Brønsted acid, so they are the compounds or substances that can donate proton, and for Brønsted bases, they are the substances that can accept that proton that the Brønsted acids give. Okay, so for Lewis so before we proceed with the Lewis acid, so let's have this again. So H plus. Okay, so this H plus, when this reacts with OH minus, so OH minus accepts the proton, so it will be H2O. So this means that OH minus is also called as Brønsted base. Okay, so at this particular example, we have H plus. So the other reactant is NH3, okay, or ammonia. So NH3 accepts this proton, so that means that NH3 or ammonia is also a Brønsted base in the definition. Okay, so it will become ammonium ion. Okay. So Lewis has a more general definition for these acids and bases. So Lewis acid, so when we say Lewis acid, they are the substances that can accept a pair of electrons. So Lewis, as we all know from the Lewis dot symbol, as well as other contributions by Lewis, he is more focused on the electrons inside the atom. So how do electrons, or how do the number of electrons change in the atom in a chemical reaction? So he is the one who did more research about it. So if we have Lewis acid as the accepting substances that accepts the pair of electrons, we have the Lewis base as substances that can donate a pair of electrons. So let's go back to the previous slide. So in this one, H plus accepts this pair of electron in the OH minus, so that it will become bonded. So that means H plus is a Lewis acid, and this OH minus, so this shares, or this gives a pair of electrons to H plus, so that means it is a Lewis base. Also with this one, so H plus is a donor of pair of electrons from ammonia or NH3, so it is a Lewis acid, and this ammonia has this pair of electrons to donate or to share with H plus, so that means NH3 or ammonia is also a Lewis base. Okay, so let's have a different example of what we have with the Brønsted acids and bases. Okay, so for example, we have this BF3 or boron trifluoride. So BF3 is sp2 hybridized. Okay, so we see that we have 3 bonds with the 3 atoms of F, so in the boron. So this means that we have S and we have 2p which are hybridized, or we have one S and 2 p orbitals that are hybridized to form sp2 hybridization. And we have another p orbital that is vacant or that has no electron for boron. Okay, so this is the 2pz. So this vacant 2pz can still accept a pair of electron. So meaning to say, so it can accept electron, that means BF3 is a Lewis acid. So if we combine a Lewis acid and the Lewis base, so for example, we have the previous example, Lewis acid, boron trifluoride with a Lewis base, ammonia. So this lone pair by ammonia will be shared to boron trifluoride to form a bond. Okay. So this bond is called the coordinate covalent bond. So we all know that covalent bonds are sharing of electrons. Okay, but this time we have this word coordinate. Okay, so coordinate covalent bond. So this is a special type of covalent bond in which the electron pair does not, or the electrons from the shared bond comes from only one substance, not unlike with the simple covalent bond in which one electron for one compound and the other electron from another compound, so they are shared. Okay, so this is just the definition. Okay. So again, covalent bond wherein electrons are shared from 2 atoms, so 1 electron each. For the coordinate covalent bond, this is a covalent bond in which the electrons comes only from 1 atom or 1 molecule, just like NH3 with BF3. So that's it. Thank you.